Okay, so today I'm going to be discussing endocrine physiology. So in endocrine physiology, basically we are going to be discussing hormones specifically. So hormones are of two types. You have peptide and then steroid hormones. So peptide hormones are water soluble membrane receptors. Means basically they interact with membrane receptors, extracellular receptors which are present at the cellular membrane, and may use secondary messenger systems to interact with the nucleus. Whereas steroid hormones are lipid soluble, so because of that they can cross the phospholipid bilayer and hence have intracellular receptors. These are cholesterol derived hormones, and these usually interact with the nucleus directly. So for examples of peptide hormones are insulin, FSH, follicular stimulating hormone, luteinizing hormone, growth hormone, glucagon, oxytocin, parathyroid hormone. And then for steroids or like steroid hormones, you have testosterone, estrogen, progesterone, aldosterone, cortisol, gonadocorticoids. Another type of hormones you could have are hormones synthesized by tyrosine, T3, T4, norepinephrine, and epinephrine are examples. Now, you have the anterior pituitary, in which there are three main nuclei. So you have the paraventricular nucleus, which deals with the corticotropic. Have the paraventricular nucleus, which deals with the thyroid releasing hormone, the corticotropin corticoids releasing hormone, GnRH, PIH, and then you have the growth hormone releasing hormone. This is the gonadotropin releasing hormone. PIH is the prolactin inhibiting hormone, and you have the corticoid releasing hormone. So the paraventricular nucleus is activated in the presence of fever, hypoglycemia, stress, low temperature, and it releases also PIH is actually dopamine. So it releases CRH and TRH. CRH interacts with the corticotrope, which is a cell present in the anterior pituitary, which causes alpha MSH and adrenocorticotropic hormone to be released. Then you have the GnRH, which interacts with the gonadotrope, and the gonadotropin releasing hormone interacts with the gonadotrope and causes follicular stimulating hormone and luteinizing hormone to be released. Then you have PIH released by the arcuate nucleus. It is often triggered due to reduced blood glucose or increased amino acids in the blood, or decreased fatty acids or exercise, and increases the release of growth hormone releasing hormone. So prolactin inhibiting hormone acts on the lactotrope and reduces prolactin production. So when the production of prolactin inhibiting hormone decreases, the lactotrope is activated and prolactin is produced. On the other hand, when growth hormone releasing hormone is released, it interacts with the somatotrope cell and causes growth hormone to be released. Then you have the thyroid releasing hormone, which interacts with the thyrotrope and causes thyroid stimulating hormone to be released.